The last type of encoder that we have to complete in this particular course is hexadecimal to binary encoder. Now you already know that in case of hexadecimal number system, the base or radix r is equal to 16, which means there are in total 16 distinct digits in case of hexadecimal number system, and they are from 0 to f. Okay, 15 is written as f in hexadecimal number system, and if you are in this encoders, definitely you have already studied about the number system, and you know that 10 is written as A, 11 as B, 12 as C, 13 as D, 14 as E, and 15 as F in case of hexadecimal number system. Now it is very clear to you that 16 is the number of input. If I talk about the number of input for our encoder, this is our encoder, n is equal to 16, and I will put it equal to 2 to the power m. So m is equal to log having base 2 16. It can be written as log base 2 2 to the power 4, which is equal to 4. So there are 4 outputs, okay, because m is your output, and the 4 outputs is the bits from B0 to B3, and we require 4 bits to represent a single hexadecimal number. For example, in encoder, if I say 5 is high and rest of the inputs are low, then B0 will be 1 0 1 0. You can see here 5 1 0 1 0. Similarly for the other inputs if they are high. So let's find out the values for the bits B0, B1, B2, B3. Let's first see for B0, and let's see for what case it is high. It is high for the input 1, 3, 5, or you can say that for all the odd, you can see 7, 9, this is your 11 for all the odd inputs. B0 is high, so I will write, let's change the color, 1 or 3 or 5 or 7 or 9 or 11, 13, 15, and I will write 11 as B, 13 as D, 15 as F. Okay, let's see for B1, and B1 is high for 2, 3. Let's write it down, 2 or 3. Then 6, 7, so 6 or 7. Then A, B, A or B, and finally for E, F, so or E or F. Okay, now we are left with 2 bits B2 and B3. So finding out for B2 and B3 is a task for you. You do it by yourself. I'm not going to do it because it's a very simple thing. So you will find B2 and B3. You can do it as your homework, let's say. Okay, now it's time for implementation. Once you are done with B2 and B3, and I have already calculated the value for B0 and B1, you can implement the circuit. I'm just going to show you the circuit. So let me paste it down. I have already cut the circuit from the book, and you can see here these are the hexadecimal inputs from 0 to F, and these are the 4 boolean outputs B0, B1, B2 and B3. So check your answer, check your circuit, and this is all for the hexadecimal to binary encoder.